You can do thermodynamics.
The reading on a mercury manometer at 25 degrees Celsius, open to the atmosphere at one end, is 43.62 centimeters. The local acceleration of gravity is 9.806 meters per second squared. Atmospheric pressure is 101.45 kilopascals. What is the absolute pressure in kilopascals being measured? The density of mercury at 25 degrees Celsius is 13.534 grams per centimeters cubed.
In metric units, the absolute pressure is equal to the height of the mercury times the density of the mercury times the acceleration of gravity plus atmospheric pressure. You are given the height of the mercury is equal to 43.62 centimeters. You are given the density of mercury to be 13.534 grams per centimeter cubed. The acceleration of gravity is 9.806 meters per second squared. The atmospheric pressure is equal to 101.45 kilopascals. Do dimensional analysis to get height in units of meters. 1 meter equals 100 centimeters. Cancel out the units of centimeters. Multiply the top values together, which equals 43.62 meters. 43.62 meters divided by 100 equals 0.4362 meters. This is the value of the height of mercury in meters. Use dimensional analysis to get density in units of kilograms in meters cubed. Start with the density of 13.534 grams per centimeters cubed. 1 kilogram equals 1,000 grams. 100 centimeters equals 1 meter. Cube both of these values. 1 million centimeters cubed equals 1 meter cubed. Cancel out units that are the same. Multiply the top values together, which equals 13,534,000 kilograms. Multiply the bottom values together, which equals 1,000 meters cubed. 13,534,000 kilograms divided by 1,000 meters cubed equals 13,534 kilograms per meters cubed. This value can be inputted into the density value. Now you have the needed values with consistent units for the first part of the equation. Inputting the values into the first part of the equation yields 0.4362 meters times 13,534 kilograms per meters cubed times 9.806 meters per second squared. These values multiplied together equals 57,890.02 kilograms per meter second squared. This is the same value in pascals. Do simple dimensional analysis to change the value from pascals to kilopascals. The derived value is 57.89 kilopascals. This value can be inputted into the first part of the equation. The atmospheric pressure is the second part of the equation. The absolute pressure is equal to 57.89 kilopascals plus 101.45 kilopascals, which yields the absolute pressure to be equal to 159.34 kilopascals. This is the final answer for this problem.
Great job! Please subscribe and hit the bell for notifications. A similar problem using British units is coming up next. The reading on a mercury manometer at 70 degrees Fahrenheit, open to the atmosphere at one end, is 27.36 inches. The local acceleration of gravity is 32.187 feet per second squared. Atmospheric pressure is 30.06 inches mercury. What is the absolute pressure in pound-force per square inch being measured? The density of mercury at 70 degrees Fahrenheit is 13.534 grams per centimeters cubed.
For British units, Absolute pressure equals the height of Mercury times the density of Mercury times the acceleration of gravity, all divided by the conversion factor for mass to force, which all this plus atmospheric pressure. The conversion factor from mass to force equals 32.174 pound mass times feet divided by pound force seconds squared. You are given the height of Mercury equals 27.36 inches. The density of Mercury equals 13.534 grams per centimeters cubed. The acceleration of gravity equals 32.187 feet per second square. And atmospheric pressure equals 30.06 inches of mercury. To help in solving for absolute pressure, the desired units for all these values are feet, seconds, pound mass, pound force, and inches in mercury. Afterwards, you will eventually need to convert pressure to psia or pound force per inches squared. Use dimensional analysis to get the density of mercury in the desired units. 1 kilogram equals 1000 grams. 1 pound mass equals 0.453592 kilograms. 2.54 centimeters equals 1 inch. Cube both of these values, which yields 16.387 centimeters cubed equals 1 inch cubed. 12 inches equals 1 foot. Cube these values as well. This yields 1728 inches cubed equals 1 foot cubed. Cancel out units that are the same. Multiply the top values together, which equals 383,238.71 pound mass. Likewise multiply the bottom values together, which equals 453.59 feet cubed. 383,238.71 pound mass divided by 453.59 cubic feet equals 844.90 pound mass per cubic feet. This is a derived value of density in the desired units. Use dimensional analysis to get atmospheric pressure in the desired units. Use 1 inch equals 0.49115 pound force per square inch. Cancel the inches of mercury units and then multiply the top values together. Since the remaining bottom value is 1, the bottom can be ignored. The new derived value of atmospheric pressure is 14.76 pound force per square inch. Now you have all the variables of the right side of the equation in consistent units. The first part of the equation is 2.28 feet times 844.90 pound mass per cubic foot times 32.187 feet per second squared, all divided by 32.174 pound mass feet divided by pound force seconds squared. Simplify units. Simplifying this expression yields 1927.15 pound force per square foot. Use dimensional analysis to get units of pound force per square inch. 1 foot equals 12 inches. Square both of these values, which yields 1 square foot equals 144 square inches. Square foot units cancel each other out. The top values multiplied together yields 1927.15 pound force. This value divided by the remaining bottom value of 144 square inches equals 13.38 pound force per square inches. This is the wanted units of psia. This value can be inputted into the first part of the right side of the equation. You have the value for atmospheric pressure, which can be inserted into the second part of the right side of the equation. Now you have the equation for absolute pressure equals 13.38 pound force per square inch plus 14.76 pound force per square inch. When these values are added together, the sum is 28.14 pound force per square inch, which can be written as 28.14 psia. This is the final answer.
Great job! You are progressing in your understanding of thermodynamics. Please subscribe and hit the bell for notifications. Please check out other videos from this YouTube channel. Keep up the great work.